Hey guys, in this video I will show how to set up the electronics part of your CNC plasma build. This will be a longer video because I want all the information in one video. There are chapters in the progress bar if you want to skip ahead. Very quickly, I just want to go over the different components. I know this is probably way more basic than most of you need, but I would rather have everyone follow than have some people get confused. I'm no expert, to be honest. I know very little about this stuff. I just know enough to get things running. So feel free to correct me in the comments below. For starters though, you have your computer. I'm using an older laptop because it is the only laptop I have that has a parallel port. The CNC control software I use is Mach 3. I like using Mach 3 and it's free as long as you don't need more than 500 lines of G-code and you aren't using a torch height controller. If you want more lines and the THC and the other features, it's only $175. The port I use is a parallel port. I know you can install parallel port PCI cards into your desktop, but I needed a laptop because I have to keep my CNC outside under a tarp due to no space in my shop. So the portability was necessary. There are other ways of controlling your plasma machine over different connections, for example Ethernet, but I have no experience in this. This leads me to the next device, the breakout board. This device is what communicates with your computer and is what sends the directions to the motor drivers after receiving instructions from your computer. This is also what controls the limit switches and where you will have your plasma cutter trigger switch connected. This device is what allows your external electronics to communicate with your computer. This is a cheap Chinese board, but I've had no issues with it so far, and I've used it on all my previous builds. The only problem I've run into is I run out of input pins, so I have to use the same pin to do multiple things. I'll show you how to do this. Next, you have your motor drivers. The motor drivers take the instructions from the breakout board and turn the stepper motor at the specified speed, direction, and distance. This is also where the motors get their current from. The wires from the breakout board to the motor drivers are only signal wires. This is why you'll see later that the motor drivers need power from the power supply. Next, you have your motors. The stepper motors are obviously what converts electrical signal into mechanical motion. I've had a few comments on why I didn't use a step-down gear. To be honest, I couldn't find a cheap system, and the machine being a CNC plasma cutter, I don't think it sees super high torque situations. I do plan on using it as a router to route wood and foam, but I think both of these are soft enough materials, I shouldn't have any issues. I do think a step-down gear would be a good thing, it just complicates things for me. Next, you have your power supply. The power supply converts the 240 or 120 volt AC voltage into a 24 volt DC voltage. I used two of them in parallel. I wanted more power, and it's cheaper to buy two of them instead of buying a single one that can support the higher power load. They are 360 watt power supplies and are rated at 15 amps and 24 volts. I've had no issues running the CNC machine off a standard 20 amp breaker. I have no idea how much power the CNC is pulling, so the two power supplies is probably overkill. Lastly, you have your limit switches. The limit switches are used to home the CNC machine, and they're also used in the floating head. Okay. Knowing the basics of the components, I'll now show what goes where and how to wire everything up. I think it makes more sense for me to show a wiring diagram, and then I'll show you how I actually wired it up. So here's kind of the outline of my wiring diagram, and so for starters, you have the power from the wall going to the two power supplies. All the lines represent more than one conductor, for example a positive and a negative conductor. So again, wall power going to the two power supplies. Next, you have the power. You have to power the breakout board. This breakout board actually needs two sources of power. One is a 24 volt power supply, 24 volts coming from the power supply, and then you also need 5 volts coming from a USB. This took me a while to figure out the first time. The board comes with a USB with two male ends, so all you need is a USB brick to plug into the wall. And again here, representing multiple conductors. So next you have your parallel cable. This one is pretty self-explanatory, but it just runs from your breakout board to your computer. So breakout board to your computer. You then need to give your motor drivers 24 volts from the power supply. So just run 24 volts from the power supply to your motor drivers. After giving your motor drivers power, you need to wire in the pulse and direction signal wires. These wires run between the breakout board and the motor drivers. This purple line is actually 4 conductors. Your pulse signal has a positive and negative conductor, as well as your direction signal has a positive and negative conductor. On the breakout board, the pulse and direction pins are the positive, and then you can wire all the grounds to the ground pin on the breakout board. The last connection is connecting your motor drivers to your stepper motors. So here you can see the different colors and the A, B label that goes with the color. These A, B labels are on the motor drivers. So then it's pretty much just repeating the same process with all the other components. So again, your direction and step for your x-axis, your motor and power, and then for your z and y. So some side notes, these pins here are for your limit switches, floating head, and THC control. Also, pin 17 on the breakout board is wired to the board's relay and is what I use for triggering the plasma torch. I have another circuit outside of the breakout board I use with this relay. Okay, now that you have an overview of how the components are wired together, I'll show you how I had everything wired on the actual CNC machine. I started off by bolting the stepper motors to the frame. Here, I'm just checking to make sure the bracket is on the correct side. Here, I'm just measuring the offset distance for the pinion gear. I showed it in a previous video, but these pinion gears don't come with a set screw hole, so here you can see why I wanted it. The motor bracket just attaches with the pivot bolt and the bolt with a spring. The pivot bolt I made tight enough where there was no slop, but loose enough where the motor can actually pivot. One thing to keep in mind is if the gantry has slop when you complete everything and have the motors on, you need to make sure the bolt with the spring is actually completely horizontal. I had this problem where one side was good, but the other side had some slop, and it was because the bolt with the spring wasn't horizontal. On this axis, I tapped the motor mounting holes because I thought the nuts on the other side might interfere with the gear rack. This bolt is too long, but I was just using it temporarily. Here, I'm attaching the Acme screw to the motor. I really have no good way of doing this and making sure it is perfectly square, so I would just recommend doing it the way you think would work best for you. You'll see later, but it really squeals a lot, and so I actually took it apart later and redid it. You can see me measuring everything with calipers to try and get it square and centered, but it's not great. The bolt holes that hold the bottom bearing are large to allow me to have some way to adjust it. I'm attaching the floating head here. I forgot to video me attaching the limit switches, but here you can see how the limit switches work. So you can see here that the linear bearing just triggers the limit switch right there. And then you have your stops. So that comes down. Then when it comes back up, triggers. And it's stopped here because of these. Yeah. That's how your floating head works. Here, I'm attaching the whole tool mounting plate. It's hard to see, but the back plate will always stay on, and I have it designed where you can take the front plate off. That way, say you want to add a router attachment, you can fairly easily switch between tools. Okay, so what I'm going to do here is just take these cables and solder them to the leads here. Just keeping in mind which cable, like blue goes to blue, green goes to green, red goes to red. So I'm just going to do all of these, and then so that all runs to this box over here, which will have all the drivers and everything. I added some plastic tubing over the motor cables to just help them stay more contained, and so it's just neater. Here, I'm stripping the wires. The wire I'm using is just some scrap wire I had laying around. Some of the wires are 4 conductors and some are 6. Ideally you want 4 conductors. Sorry it's not in focus, I didn't realize until later. I then am just soldering the wires together. I add an individual plastic shrink wrap piece for all the wires and then one big one to go over all of them. You can see now what those bottom holes on the gantry are used for. Not really necessary, but it does a lot for cable management. Here, you can see all the motor wires wired up. I have a cable carrier on the machine now to help with the cable management. Here you can see the shrink wrap on the outside. Here are the power supplies and motor drivers I use, as well as the breakout board. I cut an extension cable to use as the plug to wire the power supplies to the wall. You can also see here how I'm wiring the power supplies in parallel. You can also see here that the 2 green lights are on both. I then adjusted the output voltage to make sure the output voltage was 24 volts. I then started wiring the power for the motor drivers. I wired 2 motor drivers to one power supply and the other 2 motor drivers to the other. One power supply has the motor driver that controls the X and A axis, which is the gantry, and the other controls the Y and Z axis. I only used black wires because I had a lot of black wire, so I added red tape to the ends of the positive wires to distinguish between positive and negative. You can see how I wired 2 of the motor drivers together. Next, I plugged the power supplies in to see if everything worked correctly. They did. You can see the green lights on the motor drivers are all on. I next wired the breakout board's 24 volt power. Remember, the breakout board needs 24 volts and 5 volts of power from the USB cable. I forgot to film myself wiring all the signal cables up, but here you can kind of see how it looks. You have the positive direction and positive pulse going from the pins on the breakout board. In most cases, you'll have your x-axis be pins 1 and 2, y-axis be 3 and 4, z-axis be 5 and 6, and a-axis be 7 and 8 pins on your breakout board. The pins don't matter too much, you just need to make sure they align with what you have in Mach 3. The ground direction and pulse on the motor drivers I have jumpered together and then a single ground going back from the motor drivers to the breakout board. And this is what you have for all of your motor drivers. I then wired the motors to the motor drivers, again following the color schematic for A+, A-, B+, and B-. This was my first time plugging everything in. Definitely a little scary. I wasn't sure if anything was going to catch on fire. Thankfully, nothing did. You can see it actually moved, though this is after some configuration in Mach 3. You can hear, though, the noise the z-axis makes. We tried to fix it with some grease and lubricant. It kinda helped, but barely. So next I'm going to show you how everything looks after I got it all wired up. Going into the box, you have obviously the motor cables, but you also have the cable that comes from the computer. Goes in. You have the limit switch cables, all 4 of those. One of those is the floating head, and then you also have power, which is this green cable, and then this orange cable, this is just a voltage reading. Don't worry about that. But then you also have this is your torch triggering. So these cables, this one is my torch triggering. This is a voltage for a THC later on. But these just run over to the machine. And they come from the back of the machine. This is where it's going to be different. This is where it will depend on your machine. Like the Hypertherms actually have a connection where you can just plug in, and that's how that will work. So I have the cable. I just want to show you how this works, but when you have it attached, and then when I just see how connecting that will arc it. So that's basically what you need to find for your machine. Basically the switch on your torch. And Hypertherm makes it a lot easier versus if you're using some other brand, then you're gonna have to actually go into your machine to figure that out. But yeah, you just want it to where you can just trigger it like that. Okay, so I'm going to try my best to show you how everything is wired up in the board. So for starters, you have this green cable here that goes out, and that's to the wall. This is the main power to the board, and this goes to the power supply here. That power supply then has another cable that jumpers over to the second power supply. Basically just you have the power goes to here, and then the cable runs over the same cables run anyways. You then have this brown cable here, which is just a normal extension cable, and that has the USB brick, and the USB runs over to the breakout board. And so that bottom red light is indicating that you have 5-volt power to the board. And then you also have power from here going over to here, which is the 24-volt power for the breakout board, and that's indicated as this green light here. So going back to the power supply, you have power you have power going from the breakout board to the motor drivers, and then over to this motor driver, and this motor driver gives this motor driver power. And then same thing on this power supply, goes over to this motor driver, which gives this motor driver power. Also coming into the box, you have the motor cables, and those are wired into the A positive, A minus, B positive, B minus, and so you have those go to here, 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 and here. And then you have your signal wires. So starting with the y-axis, you have your two negatives. So your direction negative and your pulse negative are jumpered together, and this ground, which is the purple cable, comes over to here, and that's for all of them. Purple, 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 they all go to here, and that goes to the ground on the breakout board. And then your pulse positive, which is this yellow cable here, that goes to pin 2. The reason it's the Y and X axis are switched is because, again, I have the gantry is the Y or X, and the back and the axis on the gantry is the X, or is the Y. Let me say that again. The gantry is the X, and the axis on the gantry is the Y. So that's why this is switched. But so you have this yellow cable going to pin 2, the orange cable, which is the direction positive, that goes to pin 3. Now going over to the X axis, you have your yellow pulse, which is pulse positive, that goes to pin 4, and your direction positive, which is orange, that goes to pin 5. Then your Z-axis, yellow cable, pulse positive, that goes to pin 6, and the direction positive, orange, goes to pin 7. And then your A, yellow cable, goes to pin 8, and the orange here actually goes to pin 14 for me, because I was having problems with pin 9, so I just moved it over one and did pin 14 instead. And then coming here, these gray cables here are all your input cables, so that's going to be your limit switches. And so your limit switch for pin 11 will be your floating head, and then you also have 2 cables, two of them go, these 2 go into pin 13. They're wired together. It's kind of hard to see, but they're wired together, and they go into pin 13, and those are your X and Y axis limit switches, and your A axis limit switch goes to pin 15. And you can have it wired together because when you limit, or when you home the axes, it'll go Y and then X, and it's separate, so you can actually have them wired together, which saves you an input pin, which then you can use for like your THC. So I have the X and Y axis wired to the same input pin on the limit switches, and then the limit switches are all wired. They're all wired normally close. That's kind of a big deal. So it's just a full loop. And then the last thing you have here is your pin 17 was wired up to this circuit here, which is the torch trigger. So you have this wire here going to the torch trigger, and all this is doing is when you turn the relay on, it gives 5 volts, triggers 5 volts, and then this relay basically, when you give it 5 volts, it just closes the circuit. And like what I was doing with the bolt earlier, it closes the circuit and triggers the torch. So that's all that is doing. So you have pin 17 and ground going to here, and I'll show you how that circuit is exactly. But yeah, I think that covers everything. Ignore this cable. So yeah, I guess lastly too, you have your parallel port. But yeah. So I forgot to talk about the dip switches, which are these switches right here. So for starters, on is when the switch is down. So the first 3 switches are the current level, the current setting, and so I have it as on, off, off. And if you go to the top chart, it says on, off, off is 4 amps. And I have it set at 4 amps because the stepper motors I'm using are rated for 4.2 amps, so it's just a little less. And then switch 4 is whether the current is half current or like the full current, and so on is full current, so it's giving it the full 4 amps. And the last 4 I have, it's off, off, on, and that's the step, the pulse per revolutions. So pulse per revolutions, and so it's off, off, on. If you go on the chart, off, off, on is set to 2000. And I guess 2000 I think is just a normal number that a lot of people use, and so that's the only reason I'm using 2000. But yeah, so I guess I wanted to add this in just to make sure. Yeah, I wanted to add this in so you kind of knew what I was doing if you're completely lost. But yeah. So I'm about to take this relay circuit off to kind of show you a closer view of it, but I want to show you really quickly that the connection that goes to the breakout board, these yellow and black cables, so yellow goes to pin 17, black to ground, that is on the outside, and they're vertical, so that's on the outside. And then your the one that goes to the torch, these orange and black cables, goes to this white, that's on the inside, closer to the relay. So just kind of remember that because it's important. So I'm gonna go over this circuit, which and how you do it with the relay. And this is the torch triggering circuit. So I guess for basics, I just want to go over just the very basics of a relay. Basically, you have, and I'm not going to tell you the names or anything because I honestly don't know them, but basically when you give this, for this specific relay, when you give this, this circuit right here, these connections right here, 5 volts, then it will flip the switch. And so you have your normally close circuit or your normally open circuit, and we want to wire it to the normally open, so that when there's no 5 volts, then it's normally open and the torch won't be triggered. And then when there is 5 volts, then this switch will switch, and now this circuit will be closed, doing the same thing as like what I did with the bolt. So it's going to close it, triggering the torch. So I'll show you this really quick, this diagram as well. So you have your coil, I guess that's what it's called, and then your circuit. So normally closed and normally open. So for obvious reason, this is normally closed, and then when you give this right here 5 volts for this specific relay, 5 volts, then it will trigger over to the normally open side, and then closing this circuit. So we have this, and this end right here is our coil end. You can see the two leads. And then going back to this diagram, our common pin right there, the green, goes to there, and our normally open and our normally closed is like right there. And then our coil is right there. So if you follow these back, so that's on the outside, and if you remember correctly, the outside here was what went to the breakout board, and the inside is what was on the torch. And so the torch wired to the common and to the normally open, and then the breakout board wires to the coil. And so it's pretty simple. I just have this to make things nicer, but you could theoretically just solder it to your relay. And this isn't any crazy relay, it's just the name of it is a JZC11F. If you can see that. Yeah, there you go. JZC11F is the specific relay, but it's nothing special. So if you have a relay laying around, the only thing is that you do want it to be activated with the 5 volts. So hopefully that explains it well enough where you can create your own little torch triggering circuit. Really quickly, I'm going to show you where the limit switches are on the machine. So right here, you have the 1 limit switch, and basically just when the rail comes, just touches that right there. And then there's also a switch right here. And the last switch is right here on the So 3 limit switches. Then you also have a limit switch in here. I now want to go over how you set up Mach 3. Okay, so when you first open Mach 3, you're greeted by this screen. Just kind of a quick overview. The big button here is your reset, like your e-stop. So you need to turn that off. And then now you're able to kind of jog, so you can see this number is changing with the arrow key. But really quickly, this will, if you load a G-code, then this will populate. You'll see your G-code lines here, and then a preview of the part you're going to cut out. Here, start, stop, e-stop, kind of self-explanatory. Like load, close G-code, all that. This is your torch height controller, and this will actually turn on your torch. So when it's flashing, torch is on, off. And then I don't really use these 2 boxes. Mach 3 has a lot more features than I even know about, and it's a very, very powerful program. I just use pretty much the basics of it. But so in order to get your machine running, though, you do need to change some settings. For starters, if you come here, you're going to want to go to Configure and then Set Native Units. Just ignore this. This warning is basically telling you that you don't want to change this once you change it the first time. So I'm going to click inches because I'm American. Everyone else who lives elsewhere in the world can click millimeters. Once you have your units set, you want to come here and click ports and pins. You don't need to change anything on this first page, but you do want to come over here and click motor outputs. So this is the first page we'll start doing some stuff on. So for starters, you want to enable your A-axis. And then here you want to go 2, 3, 4, 5, 6, 7, 8, 9. If you remember, my A-axis direction pin was actually 14. That's because I was having problems with pin 9. But you should be able to just do pin 9. Unless you're having problems with your pin 9, then you can change to 14 as well. You want to activate these. This basically just changes the direction of the motor. So if it's going one direction and you want to go the other way, then click this or activate these and it will actually flip the direction. The way I have it wired, and it should be the same, you'll want to have these two activated, and then you just need to do port 1, port 1. That's all you need to change on that page. Next, you want to go to the input signals here. So this page is basically dealing with your limit switches and the floating head. So for starters, you want to enable the X home. It's going to be port 1. And then it is pin 13 for me. The Y home, port 1, pin 13. And then we want to find the A home, pin 1, pin 15 for me. Yeah, pin 15. So you notice we didn't have a Z home. I didn't have enough input pins if I use the THC. I haven't added the THC yet, but if I want to use the THC, then I won't have enough input pins for the Z home, and I don't really think it's very necessary. So I'm going to skip out on the Z home. Then you need to find probe. Activate the probe, port 1, and pin number 11. So, and that should be good on that. So now you want to go to the output signals. And here, so the output signals is basically to trigger the torch. So you just need to enable one output, and that's number 1, port 1. And if you remember, the torch was on pin 17. So just change that. And then I have it as active low, just because when the torch was off, when Mach 3 said the torch was off, the torch was actually on. And when Mach 3 said the torch was off, the torch was actually on. So when I click that, then it switches it and makes it correct. You shouldn't have to do anything in this tab or the next tab. It should be all good. And then here, this doesn't matter too much, but I have this activated. Again, if you're using the demo version of Mach 3, then it actually doesn't matter because you don't have access to the THC. But anyways, I have that activated. So click apply, click OK. Then you do want to come here and just say save settings. Then come back here. Next, you want to do your homing and limits. And So with that, I have, these are the soft limits. Basically, without when you home the CNC, then the computer knows where the machine is relative to like the end of the linear rails, and so it will, if you set up the soft limits, then it will actually stop the machine. It'll stop the machine from running off the linear rails. You have to have this soft limits activated, but I do have it set up, and if you're following my machine correctly, the same way as I have it set up, then this should be a roughly 51 inches. Not sure what that is in millimeters. 53 and 51, and then this is 0, 0, 0, and then this here you want to be 53, and then you want the home, that, and that. Basically, you can kind of ignore all the soft limits and all this. Really, the only thing that matters on this page is you need to activate this home negative, home negative. If you have the limit switches set up the way I have it, which is kind of different. Basically, when you home, then it will go positive versus coming closer to 0. Anyways, I feel like I'm making it more complicated than it needs to be. But this is all just for your limit switches, pretty much. Click OK on that. And then the other big thing is you need to come down to, this one definitely does matter though, the slave axis. And so I have, again, the x-axis as a slave, and so you say the slave axis is A. Some of you might have the y-axis as the slave, which then you'll say A. But yeah, so click that. And it does say restart Mach 3 after setting these selections. We won't do that, but so with those settings, you should be up and running. Things should start to move. Not correctly, but they should start to move. So next you need to set up the motor tuning. If you come here, so you have an X, Y, Z, A. There's a lot more to motor tuning than it's actually quite complicated, and I know very little about it. I just kind of go off of what I think sounds right and seems right. But for starters, there's steps. This we'll set up later. Your velocity, you're just going to want to mess around with the machine and figure out what velocity you feel is good, and acceleration. Currently, I have this as 250 and 30. And then you got to save axis settings, and then you click Y. And then on the y-axis, I have this as 500 and 15, and save. And then Z, I have this as 130, save. A, you want this to be the same as your X or Y or whatever whatever A axis is slave to, you want this the same as. So 250 and 30. And then the way we set this steps per 2000 is we click OK, and we actually go to diagnostics, or sorry, settings, you say set steps per unit. And you want to calibrate your X, and you'll click OK, and you say how far you want to go. So you want to go 20 inches. You click that. Oh, tap that. And then it'll say how far did the x-axis actually move. And you take a ruler and you say how far it actually moved. It only moved, for example, maybe 10 inches. So then you click that. So it says this will be set. Would you like to accept it? And you say yes. So now if you come over here and go motor tuning, see how it auto input that number for your x-axis. So you want to go through your X, Y, and Z. Your A is the same as your X, or your A is the same as the Y. But yes, so with those all set, you should be up and running. All you have to do now is create a G-code with Fusion, and then load that G-code here, and then open it and click start. So I guess that's it. Then you do want to come here and just say save settings. When I was screen recording the screen with Mach 3, I feel like I didn't do a great job of explaining how to set your steps per. So again, that is under the motor tuning. Configure motor tuning, and it's this number here. Mine's 849. Honestly, it should be the same if you're in inches. It should be the same, because if you use the same rack and pinion, it should be all the same. But say for some reason you're using a different rack and pinion or something, you do want to go to settings. Again, I showed all this, but you want to go to steps per unit. Now this box comes up. So now we say we want to do the x-axis. So let's say X, and let's say move it 10 inches. So now what we're going to want to do is get like a big ruler. You want to move it as big, you want to move at large distances, because you could do it with a caliper. If you could do small distances with the caliper, but the small errors add up over longer distances. So you want to do long distances. Even like a tape measure would be good. Just for simplicity here, I'm just going to do this. So you set it here. Now I'm looking at where it's marked, so you can see it's at the 23 roughly. And when you're doing it, you want to be a lot more precise than what I'm doing right here. But then you say, how far would you like it to move? And you say 10 on the X. So now it's moving 10. So now you come down here and see how it's at the 13, so it moved 10 inches. But at first it's going to move some crazy distance. And so you want to say how far did it move, and then you'll input actually how far it moved. I'm just going to put 10 because that's how far it actually moved. And yeah, then you'll say yes. And it says the x-axis has been set. Then you want to do that again, so you want to go here. Then you want to set your Y. And then now you want to say, I don't know, move 5 inches. And again, doing it off of this, you'd want to measure some distance, see where it is, have it go. Measure where it's at right now. You can measure, say, how far off of this, how far from here to there it is, and then when you say go, it went 5 inches, then you measure what it is now, and then take the difference, and then it moved 5 inches. So click OK, and hit yes again. Okay. So hopefully that helps. When I did it, I used the tape measure, and you do want it, ideally you want to go across the whole table because then you'll have less errors. If you're measuring super precise with calipers but you're only moving a couple inches, it won't be as accurate, versus if you do it with, say, a tape measure, you can go from the whole distance basically. Then you'll be a lot more accurate, and you can do it multiple times. Say at first it's really off, then you can do it again and it will get more accurate as you kind of, each time you do it. Keep in mind that, like, you do want to be, you can accidentally run it off the table, so make sure you're going in the right direction. And you can put negative numbers in when it says how far do you want to go. You can say -10 versus +10, so keep that in mind. But hopefully that helps explaining how to set your steps per unit. Okay, so I wanted to do a quick video of me homing, because I feel like I didn't do a good job of kind of explaining that. So when you do, these are all green because I've already homed it, but I'll home it again. So you want to click this reference all home. So basically, so now what you can see is, well, I have the y-axis and it's going to go till it hits that limit switch. Triggers now the X, and now the X goes until it hits the limit switches here. And this is the one that matters, because if the gantry is out of square, then this is what squares it up. So you hit both limit switches, and you do want, here you want the limit switches to trigger so the gantry is square. So you want these limit switches set up where when they trigger, it's on the same distance on both sides, so that the gantry is now completely square to the table. So now also, and then with that, now that the table, now that Mach 3 knows that the bottom left corner, now it knows where the bottom left corner of the table is. And with those settings now, if I turn my soft limits on, so you can see now there's a green box around them. So now with the soft limits on, if I jog the y-axis, see, I'm pushing the y and it's not going anywhere. So it's hit the soft limits, so it doesn't let you go off the table. And that is the same for your X over here. See, so again, pushing, and it's not letting me jog off the table. So that's all the soft limits are. More on the machine coordinates versus the part coordinates. So right now I have a file loaded. You can kind of see it's up here. That's because the machine, or the part coordinates are these big numbers. But if I go here and click 0, 0, now if I click regen toolpath, it's taking a while. But see, so now the part, so now the X, you can see where the purple lines, it's hard to, here, so you can see now where the purple lines cross, that's where the machine is. And if I go up on the Y, you can see those lines there. So basically you want to find where you want to cut the part, then zero these. But here's the difference. When I come now, after I've homed the machine, now if I come here to the machine coordinates, see now the machine is actually plus 15 in the X and plus 14 in the Y, even though it's technically zeroed on the part. So that's the difference. You don't want to see the red on this. You don't want to see the red box around the machine coordinates. You're almost never going to deal with machine coordinates. The only reason you deal with machine coordinates is when you're homing with limits. Basically you want to know how far it is from that corner of the table where after you home. So make sure you don't want any red on the machine coordinates. So hopefully that clarifies machine coordinates versus the part coordinates a little better. But I want to show you too kind of an easy trick, or a few tricks with Mach 3. One being, if you hold the shift key down and the arrow keys, then it will jog quicker at your full speed. So right now it's jogging at what? So if you hit the tab, actually going back to, if you hit the tab, then this thing comes up, and you see here I have it jogging at 60%. So you can change this to whatever you want, and that's the speed that this will jog at. But if you hold the shift key and the arrow, now it jogs faster. Now it's jogging at the full 100% speed. Another thing too is if you hold the control key down and the arrow keys, now it only moves a small amount. See, it's only moving 10 thou on the X. So that's an easy way to kind of line things up, so you can jog fast with the shift, and then once you get onto position, hold the control, and then you can make super fine movements. So it's kind of a trick with Mach 3. Wow, if you've made it this far, thanks for watching. I really do appreciate it. I hope this video gives enough information for you to set up your own electronics on your own build. If I forgot anything, or if you have any questions, definitely let me know in the comment section below. A couple things before I go. I thought about putting together a website where you can buy all the metal plate for this plasma build online, like the gantry, sides, and the motor mounts. If this is something you'd be interested in, let me know. And then lastly, I've added some footage of some recent cuts, as well as an uncut video of me cutting a part. Both of these are at the end of the video. Really, thanks again for watching, and let me know if there's anything else you want to see. Hey guys, I just wanted to show off these cuts that I did on the machine. Probably some of the best cuts I've done. This is just a random project I have going on, but yeah, so really good looking cuts. This is 1/2 inch steel. And on this machine. Okay, here's some other cuts. This is, oh, if it focuses, these ones have had some work done, but this is all, again, the 1/2 inch stuff. Like, definitely some pretty good cuts. Pretty nice. That hole. And this edge hasn't been ground yet. Personally, if I didn't know any better, I would have thought it was laser cut. Yeah, thought I would just show this one off as well. But Pretty nice. So I wanted to show you guys the steps that I kind of take to cut it out. So you have the torch right there. I have it already set out where it zeros, but this is the part. And so just make sure it doesn't run into anything. Just kind of checking the edges. Make sure I don't go off the plate. Nothing is catching or anything. And I loaded the part by doing load and then opening the part. So then once you have it all zeroed out and where you want it, so the zero for me is this bottom left, pretty close to that. You can see these are close to zero. So after you have that, then you just click start, and this is on 1/2 inch plate. So here we go. I don't know why on this part, but it always does that on that hole for some reason. I think the lead ends are too long. So there's the dross. And I really think this has a lot to do with the rust on the back. We were cutting 1/2 inch that was clean metal, and there was very little dross. So I think this dross is really all just rust. And it comes off pretty easily if I just as you can see, it comes off quite easily. But yeah, I think if we were cutting on cleaner material, then I think there'd be very little dross. This is just what we have laying around, so, but yeah, just kind of a start to finish of a cut.